Energy Switch is the popular point-counterpoint show where two leading experts with different perspectives discuss the most pressing energy and climate issues in the news today. Next on Energy Switch, we'll look again at battery technology and how it may impact our future.
Funding for Energy Switch was provided in part by the University of Texas at Austin and by EarthX.
In part one, we talked mostly about batteries for electric vehicles. Now, we'll discuss how they might be integrated into the power grid to store electricity at scale, mostly to back up intermittent solar and wind. Lithium-ion batteries may not be well suited to this task. Instead, we'll need new battery chemistries and technologies to meet the rapid discharge, cost, safety, and reliability requirements of the grid. I'll talk about all this and more with Dr. Shirley Meng is a battery scientist and researcher, a professor of molecular engineering at the University of Chicago, and a chief scientist at the Argonne National Laboratory.
We don't want to do the bandage solutions for grid. We need a visionary leader to reimagine the future grid, how it should look like. And no doubt the batteries will be a very important part, and I think lithium will be a very small portion of it.
With her is Dr. Lyndon Archer. He's also a battery scientist and researcher, and director of the Energy Systems Institute and professor of chemical and biomolecular engineering at Cornell University.
Right now, lithium-ion is the front runner for grid storage. There is a deep bench of knowledge and expertise. It's hit price points, it works, but I do believe there's going to be an evolution. We're going to need long-duration storage, and I don't know that lithium-ion could have the cost characteristics to get us there.
I'm Scott Tinker, and I'm an energy scientist. Coming up on Energy Switch, Batteries for Cars and Grids, Part 2. Let's just start by thinking about how we meet electricity demand today. What's done today to get us all this?
Well, it's a combination of things, right? And mostly things that are based on combustion of fossil fuels to generate steam and using the steam to do mechanical work that then ultimately in a magnetic field produces electricity. And so that's what we've done for at least the last 150 years. The other relatively established technology is using water, right, to generate electric power. And in some countries, in particular France, using nuclear energy, right, as a way of, again, producing steam. The steam then drives a turbine. The turbine then generates electricity.
And those all feed a grid.
Those all feed a grid, yeah.
Yeah, which has been
Over 100 years old?
Yeah.
Yes.
Pretty stable, not bad.
Well, but let's be reminded that back 100 years ago, Westinghouse and Edison, it was not that stable for them.
Right.
So one of the questions to ask really is that, are the current grids good enough? So it is a golden opportunity for us to reimagine how the future grid should look like. So we're not, I guess, not trying to put down on whatever achievement the established technology have done. Those really served as a historical purpose, and it's still powering our houses and our buildings now. It's the future part that we worry because we have this need to decarbonize, and we have to reinvent our grid.
Yeah, and I think the reinvention, someone said something to me about 2 years ago that I knew, but I didn't know, right? That every single electron that you use to power a light, to power a camera, was produced the instant before you use it, right? Yeah. And so there is a dispatchability issue that is sort of fundamental to the grid, that, when you call for power, it's got to deliver it. And I think, as we think about a future where, renewables are part of the grid, thinking about the instability they might provide is actually pretty important.
It is.
Right.
In fact, that's where storage comes in, right? This is the critical part of either storage or something that can follow that load.
So if you look at the pie chart of storage solutions, you'll see that the oldest technology is the one that still dominates, the so-called pumped hydroelectric storage, right? Where you basically use excess electric power to pump water uphill. And then at night, you basically take the water, run it through a turbine and generate electricity when you need it. It's like 98% of all storage of electric power is in pumped hydroelectric storage. It relies on things we know pretty well from just, hydroelectric power generation, and it's inexpensive.
Yeah. Yeah.
So here's
are
where
others.
you're going to hear a lot of argument here. It's because the pie chart is misleading because less than 1% of the total electricity in the world being stored.
Correct.
So I think we are limited by geography about the pump hydro, even though there are creative ideas about how to do pump hydro locally.
So, how do batteries and storage, what do they do for the grid today?
Right now, they can manage intermittency. In the long term, we hope they can manage seasonality. To get there, we need bigger batteries that cost less.
Okay. And Shirley?
So sometimes we need weeks of storage.
Yep.
Department of Energy just launched the
Long duration
Energy Earth Shot. One of the shots is this long duration storage.
Yeah.
Because
right now we have hours, right?
yes,
At best.
we can at the best do hours. If you're really pushing it, maybe days. However, we're imagining what the batteries can do and also realizing maybe there are certain things we will need the molecules to do its job.
Okay. Is it going to be lithium ion? Why or why not? And what are some options to that?
So right now, lithium ion is the front runner for grid storage, in part because there's a supply of lithium-ion batteries. There's a deep bench of knowledge and expertise about the technology. It's hit price points where, with a little bit of subsidy, it works for the 2-3 hour storage options we've got. But I do believe there's going to be an evolution. I do believe that as solar and wind total plus storage are demanded to perform, I think we're going to need long-duration storage, and I don't know that lithium-ion could have the cost characteristics to get us there.
Okay. Options to that, or?
I'm less optimistic about lithium in the grid.
You're less than that.
Even less than this.
Yeah, less than that. I think scaling of the alternative chemistry has to start now, and also we have to bring alternative solutions like nuclear. It has to start. Because for me, we don't want to do the bandage solutions for grid. We need a visionary leader reimagine the future grid, how it should look like. And no doubt the batteries will be a very important part, and I think lithium will be a very small portion of it, in my opinion.
So you have two things, alternative to batteries, nuclear and other things, but also alternative chemistries, different metals.
Different metals, and I hope all the lithium will be reserved for transportation.
Because it's just so fit for purpose for that?
And there's so little of it, right? But coming back to this interesting point, though, that Shirley raised, the thing that I have found to be characteristic of the sector is conservatism.
That's true.
And part of it is because the grid is just so complex, and the customer at the other end is just so unforgiving. When it's off, the longer it's off, the more annoyed you get. And so I think that the interesting question would be, what would be the right format to begin to, basically prove these new technologies at scale, to, allow the scientists to test their new things in some safer form of the grid that ultimately allows it to scale faster. And I've not seen that yet. I see it in Germany. They have this really beautiful Fraunhofer Institute network where they do this quite well, where they bring together, the companies that have the questions with the scientists who think they have the answer. And there's an openness in information flow that we lack, actually, in this domain.
Interesting. We talked about batteries, what they could do for the grid, and why don't we have more today?
Personal experience is the underestimate of the complexity of grids. That will be number one. Number two is actually the batteries operate on the grid experience more severe and demanding duty cycles compared to the transportation. But, we realized how demanding the grid can put the batteries are, subject the batteries to. Third one is really, when we start to put the batteries in the field, we realized the temperature can get very hot. So all the thermal management, at least for the early generation where UC San Diego put some of the first batteries in, we realized we have to put air conditioning around the batteries to manage the thermal.
Does environment have to do with that as well? Really cold climates or really hot. Would that change the safety?
The battery is just like our human body. They're not happy if it's above 40 degrees Celsius. They're not happy if it's below minus 20 degrees Celsius. On that front, I think there are a few directions of the research that are trying to enable electrolytes for ultra-low temperature.
So in defense of the battery again, it's an interesting point. There's an interesting, I would say, complement to the advancement in battery technology and use, and that is the miniaturization of sensors. And we can know a lot about our batteries now that we couldn't even 2 years ago.
Sure.
So for me, the problem learned from engineering and the science side is very clear. We have to do better. And on the other side, we would like to invite more of the industry leaders and the financial companies to work together with us because we can educate them about how much improvement has occurred and where we're going for the future of the batteries.
Yeah.
And I think there's, I think in part, Shirley, we are a bit of a victim of our own success, right? That it was so relatively straightforward to take the batteries that worked in our portable devices and then put them in transportation, and more or less, they worked. The grid is different. And I think what I'm hearing is exactly right, that there is a need to basically rethink what sort of batteries that are ultimately needed and to begin to design them for the end use.
When are we going to see it? When are we going to see large-scale batteries on the grid?
I think the biggest one now is already over 100 megawatt hour, several places in California or in Australia, but they are all lithium-ion based technologies. For the other larger scales, I think lithium iron phosphate, I heard that is the chemistry of choice because of its long life and the safety, not energy density. Correct.
When? Is it 5 years? Is it 10 years? I mean, these are solutions that we haven't really even tested yet, right?
I'm very stressed out. Everybody think batteries will solve all the problems for the grids. Let's be realistic. Right? The scaling of the batteries, even if we do it at exponential rate, we are facing the supply chain shortage, the mining challenges, and all these issues. We need alternative solutions to come in place, to play together. What I hope is in 10 years, we will really see all the alternative chemistries at scale compared to lithium. But at the same time, I'm just an academia person. So sometimes the realities can be
Well, let me ask
quite
it this
harsh.
way. As we ramp up solar and wind, if we don't have battery storage solutions for 10 years, shouldn't we keep something online? Gas peakers, I mean, we're actually legislating gas out of the world.
In my opinion, the game changer here is carbon capture technology in general, right? So the second the Earthshot was on CO2 capture. I think if we can figure out something in that area at scale and reasonable cost, the equation is going to change.
I'm just worried, are we going to be putting serious grid instability in here? We don't have solutions for batteries for a while.
I hear you, and I think what you're saying is quite real. But I would argue that, at the same time, that opportunity is galvanizing researchers to make batteries that are suitable for the grid. I mean, these are things that were not imaginable, even 5 years ago.
Sure.
And so I expect that, these goals and the reality that you identified to drive innovation in all sorts of complementary areas, and that's the excitement.
Scott, let me add one more point. So I think all the anxiety comes from the request of knowing when, right? So some folks had the timeline of 2030. I don't think we'll do it. Some folks had it at 2040. You have to be super duper optimistic and all technology work out. And some of us had the timeline of 2050, right? So I think that
2054
for carbon neutrality, to realize. And a lot of people disagree with that, we should put the timeline off that much. But it's really a balance between people who are optimistic versus more realistic. But I want to remind everyone, when I was a graduate student in 2001, I was told if I managed to do some research that battery cost come down to $200 per kilowatt hour, the world will change. That was 10 times reduction and the battery field people actually delivered. So for me, in the grid, it's really important. Let's say if we have a 10-year plan, we should develop a really proper each year. I think that is lacking right now. So
Yes.
regardless it's 2035 or 2040 or 2050, it's very urgent for our entire field to work on this roadmap right now,
Right.
how to get there.
And that roadmap, though, the part that really does confound me is just the need for so many people to be at the table for that roadmap to work. Whether the decision makers, the investors, and so forth, will really be willing to take the risk and, at the right scale, right, to make this transition. I'm less pessimistic about the technology. I think we'll get there, especially if we take this perspective that, it's not necessarily going to be lithium-ion.
Yeah.
Yep.
Investability, scalability.
Yeah.
Let's talk to the metals, and besides lithium for grid, what are they? What do you see coming, some of them?
So sodium and zinc are probably more on the forefront, going to demonstration large scales.
Right.
And then new ideas like magnesium battery, organic flow batteries, those are relatively new. I just worry about if they have enough time to realize. So for me personally, I think sodium and zinc are the top two runner.
So
front
I
runners.
would add to that, the dark horse for me is aluminum. We never knew how to make it reversible to work in a battery. And I would say in the last decade or so, we've now learned how to do that. But by virtue of its abundance, relatively low cost, chemical inertness, meaning you don't need a dry room to make aluminum batteries, and the progress the technology has made in the last decade or so, I think there's going to be a surprise there. So interestingly, the Volta pile, and people in your audience may know, this is the first battery that was made. And it basically was a simple battery that used zinc and copper. Those are the electrodes. And there was cardboard soaked in seawater, basically as electrolyte. And that was the first demonstration of an electrochemical cell. And that's roughly about 200 years ago, right?
Yep,
That was
200
discovered
years.
200 years ago. And zinc has had a bit of a resurgence because in the last few years, researchers, including my group, I guess I can say that on the show, have discovered, how to make the zinc batteries rechargeable. So they're intrinsically cheap because zinc is intrinsically cheap. The viewers might know that roughly about 98% of the material in a penny is zinc. So it's really dirt cheap, all right? So the point is that now we've discovered through really interesting chemistry and chemical engineering how to engineer zinc so it is reversible. Right. And in laboratory studies, we have zinc batteries that run at 10,000, 20,000 cycles.
And then besides batteries, chemical batteries, what are some other things that could help keep our grid of the future reliable, resilient?
So if green hydrogen or those hydrogen made from water splitting can be actually used as base load, I think that will be an ideal place where the hydrogen can make a huge impact. And for this reason, actually, I'm quite supportive of hydrogen research because if you use it as a centralized base load applications, the efficiencies are quite good.
And having a grid that allows you to move the electricity generated across state lines. I mean, my goodness, that would be amazing, right? Because then you generate the hydrogen in situ in a place that's rich with solar energy, for example, in Arizona, and you generate the power there in that state and you sell it, just like the Canadians sell hydroelectrically generated power.
I think, Lyndon, the topic is so good because, I learned so much about how fragmented the grid is in U.S. That's what I mean, that the reimagining the grid has to happen because the connectivity is between the different
Correct.
Well, we're
independent
waiting
operators.
for solar and hydrolysis to become affordable. Nuclear with methane would be interesting too, just capture the carbon.
That is, I think carbon capture has come a long way. There was a really nice competition that the Carbon X Prize ran over the last few years. And the idea was not just to show you can capture the carbon from a power plant, but to demonstrate that you could convert it into a product that can compete in the market. And, there were some interesting entries. And one of them that I really like is they discovered a way of basically reacting the hydrogen with CO2 to make a fuel, a syngas, that is very similar to jet fuel.
Interesting.
And so that's now being commercialized in collaboration with the airline industry. Right. So the capture piece, I think, is it's something we can't ignore, especially when it's coupled to capture and conversion.
Right.
Yeah, yeah.
Right.
Yep.
We've talked about sodium, aluminum, zinc. You got to put your money on a rank order. What are the top three? What's going to happen first at scale?
So my money's on zinc. I think aluminum is a surprise. Sodium is there, but sodium is even more unsafe than lithium. And so it's high natural abundance, but the safety issues, I think, will stymie it, especially, when we think about customer acceptance and insurability.
Okay.
Yeah, so I will put sodium on the top because we have a solution for the safety concerns.
Okay, interesting.
Zinc next, and I think I have to learn more about aluminum, but very happy to hear about the progress on that topic.
Okay, so we have two high-level experts, and they have a different, what's the status of each one? How long to market for each of those?
I think it's for sodium, there was a huge injection of excitement when last year China's top battery companies announced their prototypes of sodium-ion batteries. And there were also a couple other startup companies in Asia talked about the hundreds of kilowatt-hour demonstration. So I see the scaling is happening, which means they also secured some supply chains for building the sodium-ion batteries.
Interesting.
I'm hoping, in United States, we have also had a similar track record. So we're hoping in this year or two, next year, we will see some news about sodium-ion batteries being scaled.
Interesting. Okay.
Yeah.
And zinc is, it's, as I said, 200-year-old technology. So there are companies that are using it successfully for backup power supply, including, by the way, for the San Diego supercomputer. Using aqueous zinc batteries. The electrolyte is water. And it's catching on. I think just in the last year, I saw about 4 or 5 new startup companies secure funding for zinc technology. And so I think, as the community has looked at the very questions that are driving this discussion, cost, reserves, and so forth, they're coming to the conclusion that we need to invest in this technology.
Right. What do these mean for the future of energy? How do you see this playing out?
I guess we're both engineers, and we are trained to solve hard problems. We really do look at problems for what they're worth, opportunities to find solutions. And I do believe we live in really interesting times. People want to see us get to carbon neutrality. The answer is really one of sort of responsibility, that we can afford to demonstrate decarbonization at scale. We can afford to do it, and so we should be the living laboratory that demonstrates these things at scale. Some will fail, some will not. That then provides the example.
So for me, I think with the encouragement from public, from the industry, I would just be very blunt here. If we don't provide the solution for battery storage, we won't be able to reach our the decarbonization goal. Period. So it leaves us no choice. Basically, we have to work really, really hard to make it happen. Even we have about 3 to 4 terawatt-hour production each year, it will take us 10 years to complete So it's almost not solvable by battery alone. We don't deliver. We won't be able to reach our goal.
It's one of the wedges. It's one of the levers. But I really appreciate your candor and your thoughtfulness and the insights. I learned a bunch from both of you.
Thank you.
Very good.
Thanks. Very thoughtful question. Thank you.
Today, we have to generate electricity right as we use it, because we don't have grid-scale batteries to store it. Instead, we store electricity by using it to pump water into a reservoir, then release it through turbines when we need power. Batteries would be a more efficient solution, but the grid is much more demanding than cars, requiring rapid discharge and recharge, lower cost, higher safety, and long-term reliability. To meet those challenges, alternative chemistries based on common materials like sodium, zinc, and aluminum may be required. These technologies are in their infancy, but both guests agreed if we can figure out how to scale them affordably, batteries can be part of the solution to decarbonize the grid.
Energy Switch is executive produced by Scott Tinker and produced and directed by Harry Lynch. Sophie Byard is the assistant producer and researcher. Editors are Ginny Patrick, Yusef Swachina, and Jackie Kunzler. Matt Aslanian does the sound. Energy Switch is produced by Arcos Films for the Switch Energy Alliance, with support from the University of Texas at Austin and EarthX.